Okay, 3, 5, zeros of polynomial functions. Okay, we have been solving. We've talked about zero solutions and x-intercepts are all the same thing. So you have been finding those things. And when we have been doing synthetic division and long division, it's because we had higher degree than second. And that's how we factor those things to find the x-intercepts, the zeros, the solutions. I just haven't made you set them equal to 0 yet. Okay, so what we are going to do is use our long division and synthetic division to find zeros of higher degree polynomials. That's what we're going to do. So everything you've done, and then you take your answer and set it equal to 0. That's it. Pretty easy, huh?
Synthetic division.
Don't click anything.
Okay, so what are the zeros of this function? Well, the zeros are where it equals what? 0. So you set every factor equal to what? 0. So x equals 0, x minus 4 equals 0, and x plus 3 equals 0. Now I'm going to tell you right now, I'm probably not going to write all that out every time. Does that make sense? You just do it in your head, like set it equal to 0. Got it? Okay, so the first one, what does x equal? 0. The second one, what does x equal?
0.
No.
4.
Positive 4. How?
Because it's changing.
You add 4. What's the next one equal? Negative 3. So I'm a big person to list them in order from least to greatest. So the least is what?
0.
No. Negative 3. Then what? 0. And then what? 4. Now, remember a long time ago when I accidentally did the wrong notes and we talked about odd and even functions and like this and this and this and this? Yeah, this is where all that comes in. So what we will do with that is we are going to have x times x times x, which is x what? Third cubed. So x cubed was an odd function, and it's going to be a positive, so that means it ends up, and it's going to start where? Down. So from this information we just got,
Our answer.
well, this is the answer. This is the answer we're looking for, but I'm going to show you what we're going to do with that. We have negative 3, yes.
Oh.
We have 0, and we have what? 4. So if I have to start down and end up, well, it has to do what?
Go up and then down.
Now, we don't know exactly what the tops of these two are, right? Like the vertices of those. We don't know exactly, but do we know the shape? Yep. We know it's positive, so it have to end up, right? We know it's an odd function, so that has to start in the opposite direction. So it's to start it down. And it has to go through what? Through zeros. Negative 3, 0, and 4. So do we have an idea what this looks like?
Yes.
See?
Wait, how do
That's
you know if it starts up or down?
positive or negative.
Positive or negative?
Well, okay.
What?
Now, the leading, like if we multiplied this all out, it would be x cubed, blah, 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 blah,
Yeah.
whatever. So it's positive, so it ends up, and odd ones are different, right? Odds are different ways. So if it ends up, then it had to start what? Down. If I had negative x cubed, it would be ending down, so it started what? Up.
Oh, so you're not.
Can we like write something out so I remember that?
We will. We're not. I'm showing with the goal while we're doing this.
Oh,
Okay.
we're not graphing
We're
it?
not right now. We're not right this
I
second.
got
We're not right this second. Okay. So I didn't factor this one for you. So we've got to do what? Factor it. So x cubed we typically can't factor unless there's 4 terms and we can do grouping. But do these things all have something in common?
A 4.
A 4 and an x. I touched it with my hand and it decided to go nuts. Okay, so I can factor out a 4 and an x, correct? And I'm left with what?
X squared plus 4
Nope, x squared plus,
plus x squared. Plus x.
no, plus x,
Minus 6x.
not x, 6, because we took out all the x, right? Okay, so now that 4x is just going to come down in front of my answer when I'm done, right? So I need the factors of 6 that have a difference of 1.
3 and 2.
3 and 2.
Negative. Wait, no. Positive 3, negative 2.
Positive 3, negative 2. Good job. Okay, now is it factored?
Yeah.
Yes. So I set them all equal to what? 0. Now we can't factor until it's equal to 0, but this is basically equal to 0 right now, isn't it? Like there's nothing on the other side.
Yeah.
So every factor equal to 0.
X and X.
So we have 4x equals 0. What's x equal?
0.
0. We have x plus 3 equals 0. What do you got?
-3,
And you have x minus 2 is equal to 0. So what do you got?
2.
2. So x equals smallest to largest? -3, 0, 2. So it is an odd positive. So what does that tell me about the end behavior?
No. Goes down, up.
It goes down and then ends up, right?
Yeah.
So can I do a rough sketch of this graph? And when I expect you to do this all on your own, we will go in more detail, okay? See, nice thing about sketch, you just make it bigger.
That's a good arrow.
See, that easy.
Yes, I did.
Okay,
You don't have to talk to me.
so the hardest part of this is going to be factoring. And when you can't factor, you're going to have to use synthetic division, right? Or long division, but we hope synthetic. Ready, everyone? Okay, so we have x to the 4th minus gx. Oh, and then it does say graph the function. I'm sorry. You are going to have to sketch them. Okay, what did you say?
X squared plus 9, x squared minus 9.
How did you know that? You're not wrong.
Because I know my formulas.
You know, she knows her formulas. Is x to the 4th and 81 both perfect squares?
Yeah.
Yep. And do I have a difference of them?
Yep.
Yep. But we are not all done.
We said equal to 0.
Nope. We're not factored yet.
Can we take a, don't take another x?
You can do
plus
9.
3x minus 3.
Right here, isn't that another difference of squares?
Yeah.
Yep. So I have x squared plus 9 and x plus 3 and x minus 3.
That's annoying.
Okay. Well, I'm also going to tell you we can factor that.
Wait, why did you keep going? That's just x plus 3, isn't it?
It's x plus 3i
Oh, yeah.
and x minus 3i.
But you're confusing me now.
Yeah.
Nope, this is our imaginary numbers that we've done. You cannot forget what we've done.
Why?
Okay, over here we have x plus 3i, x minus 3i. Remember conjugates? Yes?
Why did you?
Do you remember conjugate pairs?
I do.
Yes. Okay, when I FOIL this, I get x squared minus 3xi plus 3xi minus 9i squared. Well, the plus and the minus 3i go where? There's 0. What is I squared, guys?
I. 1.
81.
-1. I squared equals -1. Yes? So this is -9 times -1, which would be what?
9.
Which would be 9. So it'd be x squared
Minus 9 again.
plus 9.
Oh. Well, x squared plus 9 again.
Okay, so I did factor it. You don't always have to factor that. I'm going to show you 2 ways to do it. Just a second. Okay? If you said, well, I can't factor that and left it, I'll show you what you would do. So I set all of these equal to what now? 0. Okay? So I go across. So x would equal
Negative 3i.
-3i,
3i.
3i. So plus and minus 3i
And plus or minus 3.
and plus or minus 3. Is 3i real?
No.
No, it's not a real solution. Is it going to be a 0 on my graph?
Nope.
No. Okay. What happens with this graph?
It's straight line.
I have 1, 2, 3. 1, 2, 3. This is a 4th degree even. Yes? So it is up, up. Correct?
So it's a parabola.
Wait. It's going to go down and then it's going to have some little thing happen. And then it's going to hit and go back down and go up.
W.
And it's going to be W. This right here is my y-intercept, which would be negative 81. So, scaled drawing, right? These things happen because of that plus or minus 3i. Now, if you didn't factor this out right here, if you stopped here, right there, you would still get plus or minus 3, correct? But then you would have x squared plus 9 equals 0, correct? And you would have x squared equals negative 9, yes? You have to get rid of the x squared, so you have to take the what of it, square root,
And then reruns your I.
and there's where I get my what? My plus or minus 3i. Okay? So you can factor it, which most of us don't remember to do, but you do have to set it equal to 0 right here. But don't forget your plus and minus because they always come in pairs. Always. And we're going to talk about that a little bit later today again. If I have plus 3i, I am also going to have what? Minus 3i. Every single time. 4i, 6i, whatever. If I have I, it's going to be plus or minus. If I have x plus the square root of 3, 3, I'm also going to have x what? Minus the square root of 3. They always come in conjugate pairs. Always. Because those are not rational solutions. They're not real numbers. Well, this is a real number, but it's not a rational number because I got a square root. Okay, so this is where we're going to talk about multiplicity and odd and even. I'm going to remind you of your odd and even again. Multiplicity means more than one, yes? Or one. Could be 1 or 2 or 3 or 4. The multiplicity of a zero of a polynomial function is the number of times its related factor appears in the factored form of the polynomial. That is a lot. It's the number of times the factor appears. That's what it is. So if I have x plus 3, x minus 4, and x plus 3, what are my zeros? X equals what? Negative 3 and 4. But how many times did I have negative 3? Twice. So I just put a times 2 here. Okay? And it means something. It means something important. Okay? When the multiplicity is odd, like 1, or what's another odd? 3, or 5. Okay. The graph, the function crosses the x-axis. When the multiplicity is even, 2, 4, 6, 8, it what? Bounces off the x-axis. So when I look at these pictures here, you don't need to write them down. We don't have time for you all to wait. The multiplicity of my zeros is 1. There's a 1 here and a 1 here, correct? Yes? What does it happens at negative 2 and 1? What's the graph do? It crosses? Yes? Everyone, are you looking at this graph?
Yes.
You're all looking at me like I'm crazy. The next graph, what's the multiplicity of 1? How many do I have? I have 2 of them, don't I? So at 1, it doesn't cross, it what? Bounces off. And at negative 2, it goes through because there's only one of them. I should get a different color. So down here, I have x minus 3 to what power? The third. So that's an odd multiplicity, right? So that would factor out to x minus 1, x minus 1, x minus 1, x plus 2, wouldn't it? If we factored it, that's what we'd get. So you see x minus 1 how many times? 3. So it's an odd number, so it can cross at x equals 1. Does it?
Yeah.
Yeah. It goes up and goes right through there. Now over here, I have x minus 1 to the what power? 4. So that is an even multiplicity. So at 1, it's not going to cross. It's going to what? Bounce. Think of it like this way. This is my favorite illustration. Okay, a door that does not open and close by itself. Like a bedroom door, right? I touch it one time, what happens?
It opened.
Opens. Can I go through it?
Yeah.
Yes. I touch it again, that's 2 times. What happens?
Stop.
What am I doing?
Bouncing.
Bouncing off the door. Open a 3rd time, what can I do?
Go down.
I can go right through it.
Oh, so it's like
I
X
touch it
axis.
again, which will be
4.
4.
I'm bouncing off.
I'm bouncing off of it. It's a door. An x-intercept is a door. If no one opens it, can the graph go through it?
No.
No. Make sense?
Yes.
So, even multiplicities, what does the graph do?
Bouncing.
Bounce. Odd multiplicity, what does it do?
Cross.
Crosses it. Multiplicity comes from the number of times you see the factors when you factor. So this x minus 1 squared, the factor occurs how many times? Twice. X minus 1 cubed, the factor appears what?
3.
3. Make sense?
Yes.
Do you want us
Okay.
to? Can I write something?
You need to write odd multiplicities. It does what?
Bounces. I mean crosses.
Crosses. Even multiplicity, it what?
Bounces.
Bounces. That's what we need, correct? Most commonly, what is the multiplicity? 1. Okay? 2 is the second. You typically don't get 4 or 28, but can it happen?
Yeah.
Yes. When it says write the multiplicity, like up here, I put a little times 2. Okay? I don't care what the I don't want you to write 1 every time. That's silly, correct? I care if it's more. I have 2, 3, 4, 8. Got it? Does that make sense, what I'm saying?
Yeah.
When it says state the multiplicity, if it's 1 time, you don't need to say once. But if it's more than 1, you do need to identify it. Okay. Am I good?
Yes.
Tyson? Am I
No.
good?
But okay, go.
Well, finish.
No, go.
Okay, describe the describe the behavior of the graph of the function at each 0. So we are going to do a couple different things. We're going to do the end behavior also. We're going to keep reviewing that as we go. Okay? So these are not multiplied out, so we need to think. This is called our number sense, right? If I have x minus 1 to the 4th, when I multiply that out, x is going to be to the 4th, correct? Yes? Then times another x, it's going to be to the what? 5th, correct? Then times another x, it's going to be what? 6. So when I multiply this all out and spend all day doing it, because there's like a lot of it, right? It's going to be x to the what? 6th when I'm done. So is that odd or even? Even. And it's positive, yes? So the end behavior would be what?
Bounces.
No, end behavior. It would be up, up. Yes? This graph is going to start up and end up when I graph it. End behavior is the ends, the arrows. Okay, so now I want the zeros. So I got to set them all equal to what? 0. So from the x, what do I get? 0. How many times is that happening? Once. Yes.
How do we end up with 6 when we have
Because this would be
7?
x minus 1 times x minus 1 times x minus 1 times x minus 1. When we multiplied all those out and combined like terms, I would have x to the 4th, correct?
Oh, and then you're
And then I have an x here and an x here. Okay. So I get 0
-4.
and I get -4. How many times is that?
1.
Once. And I get positive 1, and that would be to the 4th. See how I did times 4? Have fun, guys.
Wait.
Do you see how I did times 4?
Yes.
That means the multiplicity of what? What's the multiplicity?
4.
4. Okay? So, It says describe what happens. What's going to happen at the 0?
Bounces.
It's going to go through it. What's the multiplicity of 0?
1.
1. So it's going to go through.
Oh.
Okay? So goes through.
4 goes through. And then 1 bounces.
Yet, -4, it goes through. So that's going to go there too.
Because it's a 1. There's
And at 1, it's going to what?
bounce.
Why?
Because there's a times 4, it's even.
Because it's even. So this graph, if I sketched it,
Holy crap, I'm so confused.
would be -4, right? 0 and what?
1.
1. And it's going to start up, end up. So it's going to come from here somewhere, and it's going to bounce off -4, go through 0, and come back through 1. And I don't know how far it's going to go up. I don't know how far it's going to go down. We're going to leave calculus for that, and calculus will figure those out. Okay? And pre-calc, we'll get more on this, but right now we need to know what the ends do, and if I go, what the zeros are, and if I go through them or bounce. That's what we're working. That's the step we're working on right now.
I got it.
Okay?
Why don't you have trigonometry?
What?
Why don't you have trigonometry?
I do.
It's calculus and trigonometry.
It's pre-calc and trig.
Or about regular calculus.
That's after pre-calc.
I only have 2 years of math left.
So you'll take pre-calc trig. It's one class, and then calculus. Okay.
I have to take calc. You do like pre-calc first?
Yes,
Then
you do.
calculus?
You do pre-calc trig.
I was in
You all will take
geometry
pre-calc trig, except for Carly next year, and then
Me.
What?
oh, and you, unless you are. You already said you weren't
I'm
taking.
college prep.
Okay, so next one. Let's go through it. So is this going to be a real answer?
No, you have the
Nope, but we'll do it.
stupid I thing.
So it's going to be x squared equals -9, right? And then take square root. So x equals plus or minus 3i. Okay. What's this 0 going to be? 1. How many times is that? Times 5. And then the next one is going to be
-2 times 2.
-2 multiplicity of 2.
Yes.
Okay. So if I work this out, this is going to be x to the 5th, yes? This is going to be x squared. So I have x squared, x to the 5th, and x squared. So I'm going to have x to the what?
9.
9. So I have x to the 9th, which is odd. Yes?
Yeah.
But all of these are positive, so it's going to be positive. So it's going to end up, so that means it has to start where?
Up and up.
No.
Down.
Odd looks odd. Odd. Think about odd looks odd.
What does
It's
even look like?
it even goes both up or both down.
How do you know if they go up or down?
Because if the first number is positive or negative, so this is a
How
pos.
do you know if for the even one that they go both
Still
up
go
or
the
both
other
down?
If it's positive or negative.
So if it was negative.
So if it's negative x squared, it's down, down. If it's positive x squared, it's up, up. If it's x cubed positive, it ends up, so it started down.
Oh, wait, hold on.
If it's negative x cubed or odd, it ends down, so it started up.
Let me write.
It's called end behavior because we move left to right.
X squared.
And these squareds are, guys, just even powers. Not just x squared, right? And the 3 is odd powers. And I think I have another slide on that maybe. So don't freak out too much. Okay, so it says what happens. So what's going to happen at, is that a real 0, the 3i? No.
No.
It will do the.
What's going to happen here?
It's gonna down or cross.
It's going to cross. Oh, how about if I spell this right? Okay, and what's going to happen here?
Bounces.
Bounce. Okay.
Give me a second.
We're here, yep. -2. 1. We're going to start down, end up. Yes?
Yeah.
So we're going to come and we're going to go, we're going to bounce off 2, don't we? Negative 2.
Yeah.
And if something's going to happen here, and then it's going to go up. Because I have that plus 3i minus 3i. And if you don't do that curly whatever, if you would just go like this, I wouldn't count off for it. Does that make sense?
Wait, Miss Mick,
What?
would that like, so say you have like a number, another number in there,
Uh-huh.
and then like get that 3i, would that curly thing go in like in between both of them?
Well, it's going to
Or-
be equal distance on the 0. So I'm not too worried about the plus or minus 3i. You don't need to acknowledge it when you're graphing. I'm just putting it in there to show you that it is there. I am not going to take off points if you don't do some wave in it. As long as you start, your ends are right and your zeros are right, I'm good. Okay, am I good? Angela, you good? Okay, you're just writing, so I just want to make sure. Okay, what are the real and complex zeros of this polynomial function? So there is a real 0 right here at 2, correct?
Yeah.
Yes? I can see it. But I bet there's one here and where?
The
Like something had to happen, right?
had the
Yeah.
signs on it.
Something happened. So I have x cubed plus 2x minus 3x minus 6. So I need to factor it. I can factor by grouping, yes?
Yeah.
So the first two, what do they have in common?
No,
X squared.
X squared. And so I have x plus 1.
Yeah.
And the next two, what do they have in common?
3.
Negative 3. Remember, you always have to take this sign right here.
X plus 2.
So did that work?
Yeah, kind of.
No. Did that work?
No.
Why not?
I think that's good.
These aren't the same, are they?
Yeah.
So we got to figure out how to do that, right? But I know that x equals 2 is a 0, don't I?
Yeah. Put 2 in
So if I divided it by x equals 2, would I get some leftover stuff?
You get that?
I would, well, not fractions, but I'd get something. This is 3rd degree. Wouldn't I get something 2nd degree? Yeah? Do we know how to divide by x equals 2?
Yeah.
We use synthetic division.
That's dividing?
Yes, Jaden.
Yes.
That is
Oh, yeah.
Okay, so what are my coefficients?
1,
1.
1,
I'm
negative 3, and
concerned at
negative
what
6.
Jaden said.
I know, me too.
Well, in my head, I was like, we times all those numbers by each other, so I was like, we're dividing?
Okay,
But now I think about it, we do divide, don't we?
so you do it and I'll do it and we better get the same answer. So go. And you better get a 0, right?
Yeah, we
Because it is a 0, it is a factor, it is a solution, yes? Okay, so this came from x minus 2, didn't it? Did that come from x minus 2 as a factor? Because to move it back over, I'd have to subtract, right? So now I started with x cubed, so I now have x squared plus 3x plus 3. Well, the factors of 3 that add to 3 are non-existent, correct? So when we can't factor, we have to use what formula?
We can't factor, we can use what formula?
No.
I don't even know what that formula is.
You better know what that formula is. What is it?
Wait, that's
That's the quadratic formula. That's
A squared plus B squared equals C squared.
Pythagorean theorem. Okay, It is never excusable to forget either one, the quadratic formula. If you cannot factor, you have to use the quadratic formula, and those are in your brain from now on forever. Okay? I told you that when we learned it. You will not be excused to forget that.
We don't ever do it, so I forget it.
Well, that's why you're gonna keep doing it. So you might want to write it down again. The quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a.
Why are we learning like 5 lessons?
You're not learning anything. We learned that a long time ago.
I'm gonna fail
I
college.
forgot though.
No, you're not. Okay, did you write it down?
I already knew this one.
Okay, so now we need to use it. What is a?
X.
Nope. What is a? 1. Here, it's right here. A, B, and what? C. So x equals negative b, so negative 3 plus or minus the square root of 9. Where to get 9?
B squared.
Minus 4 times 1 times 3,
Which is 3.
which is 12.
So 9 minus 12.
9 minus 12 all over 2. So I get x equals negative 3 plus or minus, let's see.
0.
No. 9 minus 12 is what?
Negative
Negative
3.
3. So that is going to be the square root of 3 what? I all over 2.
Whoa.
Are those real solutions? No, but it says real and complex
Wait, Miss Vic, where did you get the I from?
because the square root of negative 3,
Then it's just 3i.
which is square root of 3i. So, comma, what else did we already know?
X2.
2. So, this is complex, and this is what? Real. So, those complex zeros are what makes this stuff happen. Okay? Now, there would be some dip there anyway, but that's what causes that to happen. So, do you see how we used what we could see? Like, we saw that 2 was a 0, correct?
Yeah.
And so, once we divided by 2, we got our power down to something we could use the quadratic formula on, didn't we?
Yeah.
Okay. Quadratic formula has to be ready in your brain to use.
It should be now.
It better be. Okay, I know it's been a while. I didn't expect for you to like, ooh, I got it. I expected you at least remember the name.
I remember.
Okay, what are the real and the complex again? Okay, I'm going to tell you right now that is 4 and 2, are they squares of each other? If I square x squared, do I get x to the 4th?
Yeah.
Yeah,
Yeah.
I do. So I could actually factor this as a trinomial. So let's look at it. So the factors of 4 that have a difference of 3. 4 and 1, right? So instead of x, it's going to be x squared minus 4 and x squared plus 1. Because we could factor that, can't we?
Wait.
Only because x squared is x to the what?
X squared.
X squared
It's X4.
is x to the 4th. So could I do it if I had this?
Yeah.
Yes, because when you square x cubed, you get x to the 6th, right? Could I square it if I had this? Or could I do it if I had this?
Yeah.
What's another one I could do? X to the what?
12.
12th minus 3x to the what?
6.
6th. Do you see that pattern?
Yeah.
Okay, so now I'm up here. Am I completely factored yet?
No, because you gotta sort out the X squares.
Yep, so this is difference of squares, yes? So that would be x what?
-2.
Minus 2 and x plus 2. Now this is not difference of squares, but are they both squares?
Where's our I at?
We're going to find it.
Don't we need it on
Yep,
that one?
we need it on this one, don't we?
No, on the x plus 2.
No. No.
X plus or minus 1i.
Okay. So Cadence says this is x plus I and x minus I. Does that work? Because when I FOIL this out, because they're conjugate pairs, yes? When I FOIL it out, the middle term's going to be gone. And negative I times positive I is going to be negative I squared, correct? And what is I squared?
1.
Negative 1.
But it's negative.
So it's negative and negative 1, so that would become what? 1. Again, if you forget to factor like this, could I just set x squared plus 1 equal to 0?
Yeah.
And then it would be x squared equals negative 1. And then I have to take the what? Square root.
Reciprocal.
And when I take the square root, it's always plus or minus, yes? And what's the square root
1i.
of negative 1?
I.
And if I took this right here and made factors, would they look like that?
Yes.
Because I would add one I over and I would subtract the other I over. So that's what I would get. So what are my zeros? X equals
Plus minus 2.
plus or minus 2
Plus
and
minus I.
plus or minus I. Well, which are real?
The 2.
The 2. Which are complex?
The I.
Complex is another word for not real, right?
So why do we have such trouble with the other one?
I don't know.
I'm kind of getting it.
Okay. So is this going to take some work and some practice to do?
Yes.
Yes. Is this taking everything we have been doing and going, there you go.
Yes.
Yes, it is. Okay, questions, guys?
No.
Nope. Now, when I say factor, are there multiple ways to factor?
Yeah.
Yes. So just because one way doesn't work, then you go to another way and another way. Yes.
I hate to be this person.
Mm-hmm.
When will I ever use this in my life?
Depends what you do in your life.
If I'm gonna be a
I
dick,
ain't gonna be doing anything that involves this.
I'm going to tell you the next 2 years, you will be your best friend in here. Okay. So what are the solutions of the equations?
what is
No.
that?
Okay. No, wait. Stop. Stop. What do I have to do?
Equal to 0.
I have to set it equal to 0. So write down the problem.
Junior high quiz meeting today during IAP room 303. Also, senior high quiz full practice will start today during IAP.
And start at setting it equal to 0. That means moving things
So you're
over,
gonna
yes?
Begin with your IAP first and then report
Yes?
to.
You going to move it left or you going to move it right? Which way?
For left.
There'll
Guys,
be
wanna move
no
it left?
open
Wait,
gym during
I moved it
IAP.
I'm going to move it right.
No
I'm moving it
open gym
left.
during IAP.
There's less stuff to move if I move it
All
right.
High school girls basketball players are
What do you want?
dismissed when the bell rings
Ah,
to report to the gym.
I'm doing this.
You're moving the 3 over to there?
I'm moving negative x cubed plus 7x minus 6. There's less stuff to move if I move it right, correct?
Yeah.
I'm always going for make your leading coefficient positive if you can. Yeah?
Yeah.
And move the least stuff. Well, x squared is already positive. What happens to my x cubes?
Goes out.
Gone.
There's gone. So I have 5x squared plus what? 5x minus 30 equals 0. So now what?
Factor out of 5.
Factor out of 5. Good job. X squared plus x minus 6. 2 and negative 3. Good job. See how your muscle memory kicks in? And then you set them all equal to what? 0. So x equals what?
Negative 2 and 3.
Negative 2 and 3. Remember, 0 can't equal 5 because there's no variable, right? So that's nothing. If there was a variable, then we would deal with that, correct? Was that bad? No. I think all we have from here to the end is just examples. But if you get to a point you're stuck, we'll go over it again tomorrow, okay?
Are we having the